This is the screencast for section 2.1, example 3. Linear correlation, how fancy, and modeling. Linear correlation, you've heard the word, when two things correlate. Correlation is when data points are clustered along a line, so they have a linear relationship. A positive linear correlation means those lines look like they have a positive slope. A negative linear correlation means means the lines have a negative slope. The linear correlation coefficient R is a number that measures the strength and direction of the linear correlation of a data set. Now R can be anywhere between -1 and 1. 1 is a perfect positive linear correlation. So in other words, like you have the line y equals x plus 5, and every single x coordinate, when you add 5, you get every single y coordinate. Nothing strays away from that line. Then if you have y equals -2x plus 7, and every single x coordinate and y coordinate are associated right on that line, you will have an R value of -1. Now somewhere in the middle there, you aren't getting a very strong linear correlation the closer you get to 0. So you can see here's a strong positive linear correlation. Here's a weaker one. Now this is basically no linear correlation. These data points do not look like they have a relationship at all. They look kind of random. This is a strong negative linear correlation, and this is kind of a weaker negative linear correlation. So this would have very close to -1. This might have -0.5. This would have 0. This would be maybe positive 0.6, something like that, and this would be very close to +1. Well, let's look at an example. To do a regression analysis, your 4 steps are up here. We're going to do each one of those for example 3. So modeling and predicting demand. Use the data in table 2.2. Oh, that sounds like a place where you should pause and type in the data. I put this one in L1 and that one in L2. To write a linear model for demand in boxes sold per week as a function of the price per box in dollars. Describe the strength and direction of the linear correlation, then use the model to predict weekly cereal sales if the price is dropped to $2 or raised to $4 per box. Alright, so our model, let's see, I've got my data already plugged in. So I'm going to go to Stat Edit to show you that my price per box is in L1 and for my X values, and then the boxes sold is in L2. I can turn on my stat plot. Graph, zoom 9. That looks like a pretty strong negative correlation. Pretty strong negative correlation. I'm going to make sure my Y1 is cleared out and then quit. Now, if you haven't done this to your calculator already, if you're not in statistics class, go to Catalog, second, the 0 key. Now we want to go, alpha's already pressed for us, so press what D would be, so x to the -1. You want to find the catalog. See, this is a catalog of pretty much everything your computer will do. You want to find diagnostic on, that I totally just passed, flew right by. Hit diagnostic on and then hit enter. That will turn on your this diagnostics on your calculator, so you will be able to see your R values. Alright, so let's calculate. Go to Stat, Calc, a linear regression, number 4, because we can see that's a linear relationship. Now we have our X values in L1, our Y values in L2. I want to store this line into Y1, so alpha Y1. And then go down to calculate and hit enter. So there it is. Our R value is a very strong negative correlation, -0.98, very close to -1. Our slope there is -15,358.93, and then our y-intercept is that. So I'm going to go to the calculator, and that line is already in Y1 for me. So there's our model. And then the question is asking, describe the strength and direction of the linear correlation. So we have a strong negative linear correlation. Then use the model to predict weekly cereal sales if the price is dropped to $2 or raised to $4. I dropped my pen and cannot find it. Did the cat take it? Where'd it go? Found it! It was under the table. Correlation. Now I want to be able to see $2 and $4 on my x-axis. So I changed my x-min to 1 and my y-max to 5. I'm going to go back to my graph. I mean, it looks a lot different, but now I'll be able to see what's happening on the x-axis at 2 and 5. So I'm going to hit trace, 2, nope, trace. Oh, make sure you're on y1, hit 2, enter. It looks like 42,904 boxes will be sold for $2. Now let's see what happens if we go to $4 a box. 12,186 boxes, almost 187 boxes. So we use the model to predict weekly cereal sales if the price is dropped to $2 or raised to $4 per box. And this makes sense to me. The cheaper your cereal is, the more you're going to sell. The now try problem for example 3 is number 49, comparing age and weight. So a group of male children were weighed. Their ages and weights are recorded in table 2.4. So I put their age in L1 and their weight in L2. So their age would be the X values, the weight would be the Y values. Draw a scatter plot of these data. Don't mind if I do. Let's see, I turned my plot on, so I'll go graph, zoom 9. There's the scatter plot. It looks like it's got a pretty strong linear correlation, not as much as example 3 did, but still pretty strong. This one's positive though. It looks like a line that would pass through this data would have a positive slope. Describe the strength and direction of the correlation between age and weight. Well, just to make sure I'm correct, I'm going to say stat, calc, I'm going to store that into Y1. My Y1 was already cleared out. And now my graph has a line through it. So I was right. The R value is 0.947, so like 0.95, which isn't as strong as example 3, which was negative 0.98. But this is also a positive correlation because the R value is positive. So when I describe the strength and direction of the correlation between age and weight, I will say that this is a strong, positive, linear correlation. The older the child is, the more he weighs.